Okay, guys, we're going to get started with Unit 5, Lesson 1. We're going to jump around here a little bit. You're going to see that I've X'd off a few things. I don't teach a lot of this the same way that you're talking about, so um, I'm probably going to go ahead and get into the homework a little bit and show you how to find the LCM and GCF just a little bit different way. But that's okay. It's good to see some different avenues here, and we'll kind of go from there. But let's go ahead down through the vocabulary. A number is composed of other numbers called factors. For example, 2 times 3 is 6. 6 are the factors, 2 and 3 are the factors, 6 is the product, right? So 2 and 3 are factors of 6. When a set of numbers has the same factors, it is called a common factor. The greatest, greatest common, and I'm going to run out of room here, aren't I? Factor, ACT, or GCF, we call that, all right, is the largest factor that a set of numbers has in common. Now, let's put all that to work here, and I'm going to move that up just a little bit. We're okay. Here we go. So it says use a factor tree, all right, to factor 15 and 60, and then organize the factors into a Venn diagram. Well, let's forget the Venn diagram. I'm going to show you a little bit different way to do this. So if I want to find the greatest common factor of these two numbers, I'm going to factor them down, okay? So what makes up 15? 3 and 5. And you'll notice I circled them because they are what we call prime. A prime has two factors, one in itself. The only way I can get to 3 and 5 is 1 times 3 and 1 times 5. Let's go over here. Okay, so 12. I can start with 10 times 6. Both of those are what we call composite. So we're going to continue factoring those down, and I circled those because those are prime. And I circle these two because they're prime. Now I have nothing but prime numbers, okay? And now I'm going to find the greatest common factor. What's the biggest number that goes into both of these evenly? So I'm going to go ahead and get set up like so. 15 is 3 times 5. And 60, and you'll notice I crossed them off, is 2 and a 2. 2 times 2 crosses off, and a 3 and a 5, okay? Now, you're going to notice that organization is a big key here. Now, what I'm going to do is go through and circle numbers that are common in both lists. Here's a 5 and a 5. Here's a 3 and a 3. Okay? So if I circle them, I'm going to go ahead and multiply them. To find the greatest common factor, I just circle the common factors that are in both lists, and 3 times 5 is 15. So the greatest number, the greatest common factor of both of those is 15. Okay? All right, let's slide down here a little bit, make sure we're okay. And I want to take a look at numbers 1 and 2 down here. We're going to do the same thing. We're going to find the GCF of these two numbers, and it's going to be a little bit tight, but that's okay. We'll get through it here. All right, so the greatest common factor, the GCF of 24 and 6. All right, so I'm going to factor 24 down. 8 times 3. And again, you could start with 2 times 12. You could start with 6 times 4. It doesn't matter. You're going to end up with the same number circled. This is 2 times 4. And this is 2 times 2. So now I have nothing but prime numbers there. And 6. 6 is easy. That's 2 times 3. So I'm looking for the greatest common factor of these two numbers. So what I'm going to do is I'm going to write these and get organized. So here's 24. And the factors of 24 are, and let me finish this out, right, 6, are 1, 2, 3 twos, 2 times 2 times 2, and a 3. And I'm going to double check those and cross those off. And 6 is 2 and 3. Cross those off. So now I've crossed off all the prime numbers. Remember, these are what we call composite. And a composite number has more than two factors, right? So what we're going to do is we're going to circle these common factors. I didn't circle these 2's because there's no other 2's down here. And I'm going to go ahead and multiply those together, and the GCF is 6. The greatest number that goes into both 6 and 24 is 6. It is. Okay? Okay. So now, that was with 2 numbers. Now we're going to do it with 3. Okay? And 3 is the same thing. We're going to factor them down, and we're going to circle up. So I'm going to start with 18 here. Okay? 18. I'm going to write a little bit smaller. So it's 9 times 2. And again, 3 times 3. Okay? I'm going to draw a line to separate. Keep it a little bit tighter. 24. And guess what? If I cheat a little bit, there's my 24. So I'm just going to use this data over here. So I'm just going to leave that one blank. Because I already did that, right? And let's go to 60. 60. 6 times 10. 2 times 3. Those are both prime. And 2 times 5. Okay. So let's kind of draw a line. And I need this area to work. Okay, so now you'll notice back over here I got organized. I have to get organized over here. So I'm going to write 18, draw a line. I'm going to write 24, draw a line. And I'm going to write 60 and tee it up. So next to 18, I'm going to put a 2, a 3, and a 3. So 2 times 3 times 3. Next to 24, I'm going to refer back to this. I already did work. There's no reason to do it twice. So I have 1, 2, 3 2's and a 3. 1, 2, 3 2's and a 3. And then next to 60, I have 2 2's, a 3, and a 5. So a 2, a 2, a 3, and a 5. Double check it. We're in good shape. Okay, so now let's take a look at this. I want to make sure that my camera's still good. There it is. And what we're going to do in this instance is we're going to circle all the numbers that appear in 3 lists. So here's a set of 2's. Circle them. Here's a 3. Here's a 3. Oh, there they are. Right? I'm not circling this 3 because there's none here, and I'm not circling the 5 because nothing has no other number has a 5 in it. So excuse me. So if they're circled, I write them down and I multiply them. And the GCF of of these 3 numbers is 6. So the biggest number that goes into all 3 of those is 6. And that's how you find the greatest common factor of a number. Let's flip it over and let's talk about multiples a little bit. Okay, let me make sure my camera's okay. And let me adjust that just a tad. So when we talk about multiples, we're going to talk about something called the least common multiple, or an abbreviation for that would be the LCM. And a little bit different, but we're still going to use the factoring method. Okay. I just think it's easier. There's a little bit of confusion, but I am going to show you a different technique when the numbers are smaller. So anyway, let's get started here. A multiple of a number is the product, P-R-O-D-U-C-T, of multiplying that number by another. So for example, the first 5 multiples of 7 are 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, and 7 times 5 is 35. See, I took that number and multiplied it by another. These are the multiples of 7. The least common multiple is the smallest common multiple of a set of numbers has in common. Okay, so now we're going to kind of focus on that down here. Okay, so list the first 10 multiples of each number. Okay, I usually don't go that far. I'll go 5 or 6 just to save a little bit of time. But since it's asking for 10, I guess we could do that. So let's go. 4 times 1, 4 times 2, 4 times 3, 4 times 4, and I'm just going to continue. 4 times 5, 4 times 6, 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. And we're up to 40. The multiples of 9. 9, 18, 27, 36, 45. What's next there? 54. That's 9 times 6. 9 times 7 is 63. 9 times 8 is 72. And I'm going to stop there just because of the reason. So When we list the multiples, and we have these numbers that are more manageable, it's easier just to list them out. But when we look at this, what we're looking for is a common multiple. So what I'm looking for is a number that appears in both lists. And if it appears once, all right, it's going to appear more than once. But you're going to notice that I'm circling the number 36. So the LCM of two numbers is 36 in that case. Okay. Sometimes you need to go a little bit bigger in one list than the other, and that's just the way it works out. Let's take a look at 3 and 7. Okay. All right. So let's find the LCM of 3 and 7. Now, there's a coincidence here. If I take 3 times 7, I'm going to get 21. I know that the LCM of those two numbers is 21. That's a coincidence. That's going to give you a common multiple, but not always the least common multiple. So let's go ahead and list these 3's out. 3, 6, 9, 12. And I'm just counting by the number now, right? 15, 18, 21, 24, and 27. And now I'm going to list these out. And since I listed all these out, I'm just going to look until I hit one of those, right? 7, 14, 21, and there it is. So the LCM of those two numbers is 21. But let me ask you this. If the first one is 21, what would be the next one? So I would just add 21 to itself. The next common multiple is 42. And then to find the third common multiple, I would take 21 plus this. So 21 plus 42 is 63. So these are the common multiples of those two. But the least common multiple is 21. Okay? Okay, we're going to do one more together, number 5, and take a look at it. And let me check my my camera here, and we're in good shape. Ella and Ethan planned a barbecue for their soccer team. They purchased 60 hot dogs and 48 individual bags of chips. Okay. So if each person will receive the same amount of food and there will be no leftovers, then what is the biggest number of people they can feed? Okay, so they're kind of giving it away here a little bit when they say greatest. When they say greatest, right, we want to find the GCF of these, okay? So when we're looking at this, we kind of got to, get into this. What is the greatest number here? Apply your understanding of factors and multiples here. Okay. So first up is I'm going to write these out, all right? And I'm going to factor 60 and 48 here, okay? And I'm not going to do B because of space, so let's do 60. All right, 6 times 10, 2 times 3, 2 times 5. I'm going to circle all those because they're prime. Right? And let's do 48, right? 6 times 8, 2 times 3, 2 times 4, and those are both prime. All right, and let's circle those. So these are all the prime numbers. If I multiplied all of these, I would get 48. If I multiplied all these, I would get 60, right? Okay, with that being said, let's go ahead and list these out, 48 and 60, and get organized. I'm going to come back over here because I have a little bit of room. Okay, 48. So the prime numbers of 48 is 1, 2, 3, 4 twos. 1, 2, 3, 4 twos. All right, I'm going to cross those off, and that's a 3, right? And the prime numbers of 60 is 1, 2 twos, a 3, and a 5. And I cross those off. So I'm in good shape. So now, if you remember from the previous page, we're looking for the GCF, the greatest number. So we're going to circle the common factors. And you can circle any ones that are common in both. And there they are. There's no other 2's down there, and there's no 5 up there. So if you recall, when we're looking for the GCF, right, we're going to take the circled numbers and we're going to multiply them, right? Okay. So when we look at this, okay, we multiply. 2 times 2 is 4. 4 times 3 is 12. So what is the greatest number? All right. What is the greatest number of people that they can feed with no leftovers? 12. 12. Okay. So that kind of in a snapshot gives us a little bit of an introduction to multiples, the LCM, and the factors or the GCF. We're going to do more of this tomorrow as a warm-up, but this was just in case you were absent. Okay, guys, I'll see you later.